Good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know, we're all about bringing conservation, adventure, and science into classrooms around the world. We are joined right now by four classes from across North America, so I'm going to give them a chance to do a bit of a shout out. We've got Mr. Elsa's grade 6th class in Burlington, Ontario. Hi, guys. Hey! We've got Miss Waver representing a whole bunch of kids from around the region in Ojai, California. Hi, Miss Waver.
Hello.
Hello. We've got Elk Knob Elementary's kindergarten group, a whole ton of students in Virginia. Hi, guys.
Hi.
And we've got Miss Penfold's K through 7th in Orangeville, Ontario. Everybody in Orangeville, Ontario, it looks like. Hi, guys. Hey. Of course, the reason you guys are here today is for our speaker. We are joined live from Boise State University's Intermountain Bird Observatory, the Lucky Peak Research Station, with Heidi Carlisle. Some of you were in her hangout the other day with raptors. Today, we are going to be doing some songbird banding. Sounds like a lot of fun. And without further ado, I'll turn it over to you. Thanks so much for joining us, Heidi.
All right. Hi, guys. How's it going? So, like Jesse said, my name's Heidi. I'm the Education Outreach Director for the Intermountain Bird Observatory. And today we're at our Lucky Peak Research Station, which is just outside Boise, Idaho. You guys can see the forest behind me and around me. We're in some Douglas fir forest on a ridge in the mountains just outside of Boise. And today we have our songbird crew. You guys can see them behind me, and our little yurt, our little banding station building that we use. So today we're hoping to catch some songbirds and show you guys some of the migrating bird research we're doing. So we're doing research right now because it's fall. So birds are migrating, they're heading south. A lot of birds are heading south for the winter, and they're going to end up in places like Mexico, California, maybe even Central America. Other birds, though, are coming from Canada and Alaska, and they're coming down to us here in Idaho, and they're going to stay the winter here in Idaho. So we're going to be catching a mix of species today that I'll hope to show you guys. So one of the reasons we do our research here is we are on this mountain ridge. And so this ridge runs north-south, and we have the Rocky Mountains to the north of us, and then they funnel down in this narrow little strip, and they end right here at our research station. So any bird that comes from the north of us, they get funneled down these mountains. They like to stay in the mountains during migration, and they like to stay in the forest. And so we're kind of their last stop before they head out and they have to go over a bunch of desert. And so we see these big pile-ups of birds where migration is happening, and they all come here and they kind of wait and get ready before they prepare for the long journey across the desert. So one of the things you guys will see us study and measure today is the fat on these birds. And for migrating birds, fat is really important, and being fat is good. So fat, you can kind of think of it as like, instead of you guys where you might pack a lunchbox or a snack and take it with you to school, birds can't carry a little lunchbox in their beak, right? And so instead, they have to eat all at once when they have food, and they pack on the fat. And that's their energy, that's their snacks that they get to take with them on migration. So we're going to be looking for fat birds today. And our research station and the habitat around us is, we've discovered, really good for migrating birds. So we measure their fat, and we look at how fat they get. And by looking and seeing that birds are fat here, we learn that this habitat is valuable. So we have lots of bugs for the bug-eating birds. We have lots of fruit. We have lots of bitter cherry and choke cherry and serviceberry. So the fruit-eating birds can get some food there too. And then now that things are kind of drying out and it's heading into fall, there's a lot of seeds, so grasses and other plants that have made some seeds for these birds. So that's kind of what we're doing, and I should introduce, I forgot to say, so our station has been running for 20 years. And that's really important because for scientists, one of our key things that we like to do is what's called long-term monitoring. So instead of just doing a quick study, coming somewhere for a week and being like, oh yeah, okay, I kind of have some information about what's going on, we really like to dive in deep and look at how things are changing over time. So especially as we start looking at climate change and how that might affect birds, what we really want to do is make sure that if we see population trends, we're able to help those birds out. So the key with a lot of our research is we want to do conservation. We want to help birds. We want to make sure their populations are doing well. And we really want to share our information with other people who can help us make a difference. So as scientists, we can collect the information. We identify, hey, this population isn't doing well. Something is changing. Then we can tell other scientists, hey, we need to figure out what's causing this change. So our research is all about detecting if there's a change, so finding out if something is happening. Then we can do more research to find out what exactly is causing it. So is it, a big forest fire that changed the habitat for the birds? Is it climate change? Is it a big city that is really dangerous for birds when they're migrating and they might run into windows while they're migrating? So we can then follow up and do some deeper research on that. And we hope, too, then, that we can share this information with, government officials and people who can make a difference and change the laws or change the rules to help protect birds. So that's our ultimate goal, is to give people the information they need to work together with us and protect birds. So I think our scientists just went out to check the nets. And so they should be back here soon with our first batch of birds for the morning. I should say that so the way we catch our birds is we have these really fine nets called mist nets. And maybe I'll take you guys up to check out a mist net before we end today. But it's this really, really soft mesh. And when the birds run into the mesh, they get caught they hang like in a little hammock. So they're just laying in the net, and we go around and we check the nets and we pull the birds out and bring them back to our banding station. So you guys will get to see us catch these birds, measure them, weigh them, and we put a little tag on their leg. So let me go, I'll pull out a band so you guys can kind of see what we're doing.
We're just fixing pliers.
Oh, you guys are fixing pliers, all right. Can I have a band to show these guys? There we go, thank you. All right. So we have these little aluminum bands. They're really lightweight. And each one is stamped with a 9-digit number on it. And so these birds, kind of like a phone number, where no two people have the same phone number, each bird will get their own number. So these bands allow us to identify the birds, kind of like a name tag, and they're going to wear this little name tag for the rest of their life. And this will let us identify the birds, but it'll also let other scientists, if they catch these same birds, they can give us a call and say, hey, we caught your bird and it ended up in Arizona, for example. And so we can get a lot of great information just from that tiny band. The really neat thing about bird banding is that the bands are very lightweight, so they fit just like a watch or a bracelet around the bird's leg. And so just like you wearing a watch or a bracelet, it's not going to bother you during the day. It's really lightweight. It's not going to weigh you down. So it's not going to stop the birds from flying. And so it's just a really great way to get some really good information on these birds. So we always hope that we can recatch somebody else's bird. That's really exciting. And so this week, actually, one of our groups that works south of us recaught one of our sharp-shinned hawks that we banded here. And so we learned how fast that bird moves south and where it went. But we also catch our own birds a lot. And that's really great because it can give us information, like I mentioned, about how fat they are. So we want to see how fast they're getting fat here. So sometimes we'll catch a bird one day and it'll weigh 9 grams and it weighs 10 grams. So that can really change over time, and that gives us a lot of good information about these birds. So Leah has a bird. Woohoo! So we're going to watch our scientists measure and tag this little bird. So I might try to switch the camera around, and we'll talk about what Leah's doing. You get to be the star, Leah, since you brought a bird back. All right. Uh-oh, is my camera switching?
Frozen. There you go. Now you're good.
That work. So Leah has this bird in a little cloth bag, she's going to safely pull it out, and what you guys will get to see is she's using a grip called bander's grip. So she has her fingers over the bird's shoulder. Oh, look at this little guy. So we've got a little orange-crowned warbler here.
And it's a male.
Oh, and it's a male, so you can see his little orange crown. Nice. So this is a tiny little songbird that might breed here in Idaho. It might have nested north of us in Canada, and it's heading south, so probably heading to the southern United States or maybe even into Mexico. So Leah's going to read the band number and then attach that band to this little orange crown warbler's leg.
473, yep.
So we have special pairs of pliers. Oh, and I'm going to grab one to show these guys. So we have special pairs of pliers that have a hole right here. Sorry, it's not focused. But this hole allows us to close the band around the leg of the bird without even touching the bird's leg. So you'll see Leah put this little band on his leg. And it closes, and then, like I said, it fits just like a watch or a bracelet. So it's loose, it can spin and move up and down. And then those little numbers on there will tell us if we catch this bird again, we'll know which bird it was. So we're also measuring its wing. So kind of like when you guys go to the doctor's office and they measure how tall you are. So this little ruler we tuck under its armpit. There we go.
57.
And then we've got Steve here recording our data. 57 wing.
And 45 tail.
45.
So we record a whole bunch of information. You guys can see our sheets and sheets of birds. Each row going across here is a different bird that we've caught.
982.
Whole band?
So one of our other scientists, Aya here, she's got a white-crowned sparrow. So this is a bird that nests in Alaska or Canada and is coming down here to Idaho.
2821.
It might stay here for the winter, or it might go farther south. We'll be looking at the fat on this bird's belly to see if it's really skinny. That might mean that it's not migrating anymore, so that might mean it's going to stay here in Idaho. If it's really fat, that might mean that it's thinking of continuing its journey, so it has a full gas tank of gas ready to continue flying south. So Aya's got the band on her little sparrow there. And so along with the wing and tail, you'll see we'll actually blow on the belly of these birds. And we can part the feathers out of the way. Oh, and let's see, Leah's doing this here. Try not to make you guys too dizzy. So we can blow on the belly of these birds. And let's see, can you... Oh yeah, there we go. So we can see that little orange crown's chest muscle underneath. And the crazy thing with these birds is so thin that you can see their fat and their muscle through their skin underneath their feathers. So it would be like if you guys lifted up your shirts and looked at your tummy and you could see all your muscles and all your intestines and all of your insides.
71.
So they have very, very thin skin. You can see we're really gently handling them with this bander's grip. So our fingers are supporting them. We have the two fingers over their shoulders.
67.
And that's sort of like if you guys have ever been on a roller coaster ride and you've had those big, heavy shoulder straps over your shoulders. It makes you feel really safe and it holds you really secure, but it doesn't squeeze you too tight. And that's the key with these birds is we want to hold on to them so we don't let them get away, but we don't want to squeeze them too tight.
Do you want to watch me weigh it?
Ooh, yeah, sure. Let's follow Leah. So the last thing we do before we let the birds go is weigh them. Try not to make you guys too dizzy. So we'll go inside our banding yurt. You can see how this is where we store all our scientific equipment. And we put them in these little tubes head first to weigh them. So here we go. Head first. Nice.
8.2.
All right. Is this guy done?
Yeah, we're going to give it to Jeremy, though.
Oh, all right. So one of the things we're doing this morning is we're taking birds. Whoa, sorry, I'm going to get you guys really dizzy. We're putting birds into a little recording studio to record the sounds of their calls. So you guys can see this little recording studio over here. So we're going to put them in there for about 5 minutes and play some calls and see if we can get them to call back to us. What we're doing is we're trying to get a library of bird calls so that we can listen at night and figure out what birds are flying overhead. So we can't ban songbirds at night, and we hope that by recording them, we can detect which ones are flying over without anything else happening. Oh, and I'm starting to get kind of an echo, and it looks like my video maybe got lost. You guys see me?
Yeah, it froze, but that's okay. Just recently.
All right. You guys can still hear me? Yeah.
I'll hear you.
Oh, probably not because it doesn't focus very well. And my video feed just went out, so hopefully it comes back. Well, so I guess if you guys can't see me, I can tell you a little bit more about our... Oh, you see me now?
Video's back, yep.
Okay, good. I'm still hearing an echo, so maybe somebody's like off of mute or something.
Yeah,
but, all right, so we've got a couple birds. Leah's starting a new bird. Aya just finished her bird, I think. And is that one ready to fly? All right. So you guys will get to see us release one of these birds back into the wild. All right, so we'll follow Aya. So this is that little white-crowned sparrow. Get a nice close-up. You see his little orange beak. And let him fly off. Woohoo!
Awesome.
Cool. So we're going to hope this little white-crowned sparrow takes off, maybe gets caught by another scientist so that we can learn about where it's traveled to. Or maybe we'll catch it again and we'll learn a little bit about how fat it was and then how much fat it added. Okay, let's see. I'm still getting an echo and it looks like my video froze again. So you guys will notice we're catching a lot of birds this morning. So we caught, I guess, 4 or 5 in that one net check. During a full season, we'll actually catch between 5,000 and 7,000 birds. And so this is just a small sampling of the different birds we catch. Right now, we're catching a lot of birds that are shorter distance migrants. So our really long distance migrants have already left us. They've already continued farther south to Mexico, Central America. And then it's our shorter distance guys that are coming in late. So this is kind of the end of the song. So these birds are kind of the last ones to go. So they're kind of the last place in the race of bird migration right now. All right. I think we're back. So let's go, while we have some video, let's go check out Leah's bird, if she doesn't mind. So one of the things Leah's doing is she's actually blowing on the head feathers of this bird to figure out how old it is. So just like human babies, when we're born, we have a soft spot in our skull, and it's kind of squishy. Our skull isn't fully formed. Birds are the same way. So they're actually born with one layer of skull, and then as they get older, they grow in a second layer of skull. And so we're looking on the top of their head. We can actually look under their feathers, see through their skin, and see their skull developing. So if it's a thin skull that's just a baby skull, we'll actually see the pink color showing through, which is the pink of their brain inside their head, which is pretty unbelievable. And then as they get older, that skull hardens, it turns white, and then we're able to see that it's an older or an adult bird. So Leah has a little ruby-crowned kinglet. It's really nice yellow edging on those feathers. You can see as she spreads its wing. And is it a male or a female?
It's a female.
So
no crown.
Male ruby-crowned kinglets have a crown. This is a little female, so she doesn't. Oh, it looks like I lost your guys' video again. So ruby-crowned kinglet is one of the smallest birds we catch. They actually weigh only about 5.5 or 6 grams. So to give you guys a little bit of a comparison, an M&M or a Skittle weighs about 1 gram. So this little kinglet weighs as much as 5 or 6 Skittles. That's it. All right, sorry we lost the video. We'll have to, when the video pops back, we'll have to go visit another bird that we're banding. If the video's dead, but you guys can still hear me, I'd be happy to take questions while we're waiting. Oh, now it came back.
Yeah. Your video's good, and I need to keep mine muted so that there's no echo for the classes. But if you're okay with questions as you're checking something out, I'll get the first class to ask one.
Yeah, sure.
I think they'll want it for audio.
Oh, you want to see?
Great. All right. So, Mr. Elsa's class, if you guys want to start us off with a question, go right ahead.
Slightly over towards camp, if you could get some more consistent reception.
Yeah, let's take your time, guys. Thanks, out. Anyone have a question? Mr. Elsa's class?
We have one. She's just off camera.
What is the heaviest bird you've caught? What is the heaviest bird you've caught?
Did you say what's the heaviest bird we've got?
The heaviest.
What's the heaviest bird we've caught?
Yeah.
Ooh. The heaviest, I think, would probably be a golden eagle in our hawk trapping station, but what's our heaviest songbird we've caught, Jay? So here's Jay, one of our scientists. What's our heaviest bird we've ever caught as in a songbird station?
Sellers jay or northern flicker.
Oh, yeah, northern
Or,
flicker. They're
well,
pretty
we've
big.
caught Cooper's hawks.
Sometimes Cooper's
Songbird
hawks. Yeah.
And just so people know, I'm standing here holding my arm like this because I have a bird staying warm, not just because I like to stand like this.
So when it's cold in the mornings, sometimes we'll tuck a bird in our shirt to warm them up before we let them go again. Cool.
Yeah, those seem like the
Cool.
big ones.
Yeah, so northern flicker, which is a type of big woodpecker, or Steller's jay. You guys might have those in places you live.
Is there video?
I don't know if my video's available, but I'm trying to look at a little Wilson's warbler that Jay was warming up in his shirt. Maybe the video will come back. All right, that was a good question. Does anybody else have a question?
Yeah, let's head to Miss Nicodem's class.
Oh, he's showing.
Yeah, elk knob, guys.
Say it again.
Right here.
Your bird sing.
Oh, here we go. What's that?
Say it again.
What was the question?
Sing.
Oh, why do birds sing? That's a good question. So a lot of our songbirds sing for two reasons. So they'll sing to attract a mate. So the boys are trying to sing and show the girls how beautiful they are and try to attract a mate. But the boys are also singing to fight with the other males. So they might sing to be like, hey, I'm really tough and you should stay out of my territory. So they'll use it to guard their territory and the place that they live. And so that's why they mostly sing in the spring and summertime, because that's when they're nesting and that's when they're trying to attract mates. All right, my video keeps going out, but I'm glad you guys can still hear me.
We can still hear you. It's all good.
All right, good.
Favorite class, if you want to pass along any questions, so they can send them to you, and then I'll ask you in just a minute. While we're waiting for that, we'll go to Miss Penfold group. You guys have a question? Come on up. Yeah, you're good.
Closer. Right into the computer. Okay.
Hi. My name is Roberta. I'm in grade 5, and about I have a question about how is it how is the temperature like in the places that you guys are in?
Oh, what's the temperature like? So you see, I'm wearing 2 jackets this morning, but no mittens, so it's kind of in between. I think it's probably 45 or 50 degrees this morning. When we started our research this season, it was 90 or 100 degrees, so we start our research in mid-July. By the time we end in the middle of October, it's going to be even colder, so it'll be down to 20 degrees at night and sometimes not getting warmer than freezing. So I guess if you guys are in Canada, I should say Celsius. So it by the end of the season, it'll be below 0 Celsius. So it'll get colder than this. It's a little bit cold this morning. it's kind of just the first few days of fall, so I'm just getting used to the temperature still. Uh-oh, do I still have
doing
you?
Celsius
Yeah.
as well. Miss Wavers. Yep, you're still on. Yep, you're good.
Okay, good.
Miss Waver, if you want to pass along a question, go right ahead.
Absolutely, thank you. So our students are all over the world, and they're sending me questions by text and in a virtual classroom that we have. I have a couple of questions. Amanda is in 9th grade. She's in Indiana. And Anna is actually in Panama City, and she's in 7th grade. And the questions are kind of similar. One is, how many different breeds of birds do you band? And the other is, how many birds do you band in the course of a month?
Oh, cool. So total for the whole season, if we have a really good season, we'll catch about 60 different species of birds in our songbird banding station. Over the course of 20 years, we've caught more than 100 different species of songbirds in our nets. We also catch about 20, or we see about 20 species of hawks a season, and 2 or 3 species of owls. So pretty good variety. And if you're in Panama City, that's awesome, because some of our birds, like Swainson's hawks, will actually be flying over you after they leave us here in Idaho. So that's pretty cool to imagine. These birds are connected from us here in Idaho all the way down to Panama.
Very cool. All right. In the middle of our hangout, we were joined by Miss Durnan's class, grade 9s in Clinton, Ontario. You guys just have to demute your own mic. So if you go to the top of your screen, little microphone symbol, once you do that, there you go. You're good.
Okay. So I just have a question about bird lungs. I know they can breathe a third more air than we do, but I just want to know exactly how that process works.
Ooh, that's a really good question, and one of the coolest things I think about birds. So there's actually a really cool animation that you can get from the Cornell Lab of Ornithology that you should check out, because that would be give you guys a good example, but I'll try to explain it to you guys. So humans, when we breathe into our lungs, and then we breathe out. And when we breathe in and out, we never fully empty our lungs out. So about 30% of the air in our lungs just stays each time we breathe. So if you guys try to practice right now and try to breathe out, you still have some air in your lungs when you breathe out. Birds, they breathe in a circle. So they never have leftover air in their lungs. So let's say this is a breath of air. So they breathe in a breath of air, and it goes into these parts of their body called air sacs. So they're not lungs, they're kind of air storage containers. Then when they breathe out, that air goes from the air sacs into their lungs, so it doesn't go out of their body yet. Then when they breathe in again, it goes into other air sacs farther down, and then they breathe out, and then it finally comes out. So it takes birds 2 breaths of like to have their air come out of their lungs. So that makes birds really efficient at breathing compared to humans. And it's actually one reason, you guys might have heard the saying, the canary in a coal mine. So back a long time ago, before we had scientific instruments to measure the air, and back when mining was extremely dangerous, miners would take canaries in cages down into the coal mines, because you might get carbon monoxide gas or some other dangerous gas coming out during the mining process. And so they found out that the canaries, if they stopped singing, they would pass out from the gas before the humans would. And so it was a signal, and it was a way for the miners to be safe, because those canaries were way more sensitive, and they picked up those toxic gases a lot faster than the humans. So then the miners knew they had to run out, get fresh air, hopefully wake up that poor little passed out canary. And it's probably a good thing that we don't do that anymore, because those poor canaries probably had a really interesting life following those miners around. But it really demonstrates how efficient birds are at processing gases.
Outstanding. And for all the classes too, I've just passed along that Cornell Lab of Ornithology link, so you guys can check that out online if you're interested in a little more.
Awesome.
All right, let's go back to Mr. Elsa's class. If you have a question.
My question is, what made you want to go into the bird banding business?
So I started out when I was a kid, well, I always liked animals. And in maybe third or fourth grade, I was really, really interested in birds and bugs. So both. I thought they were both really cool. And I think I liked them because you can go anywhere and find birds or insects to look at. So anytime I was out in a park with my family or camping, I got to see all these different creatures. And then probably in about eighth or ninth grade, I decided I liked birds. And the way I actually found the Intermountain Bird Observatory where I work now was as a freshman in college. I started volunteering for these guys. So I came up one day, I'd never seen bird banding before, and I asked them if I could tag along. So I came up here, got to see birds in the hand for the first time, and I got really interested from seeing birds up close, which is really fun and amazing, but also seeing all the information that we collect and the ways that that information helps birds. So as a bird lover, I realized that I could actually do something. So I could be a scientist and actually do something to help birds. So that's kind of what got me hooked. It's always fun and different and new. And bird banding gives us such cool information that's basically the favorite part of my job.
Outstanding answer. You're just like glowing with this. You love what you do, and we love that. All right, let's go back to Elk Knob.
All right,
Go ahead.
can birds get too fat?
Can they get too fat?
Mm-hmm.
So the cool thing is birds can't actually get too fat. And doctors are trying to study that because humans, we can get too fat, right? And that can be bad if we get too fat. It can make our hearts unhealthy. It can make our circulatory system unhealthy. But birds, they can get as fat as they want, and their heart is still okay. They never get diabetes or any of the illnesses that humans get when we're too fat. And so doctors are actually trying to study, how can we help humans by looking at the way that birds' bodies work differently from ours. So yeah, for birds, being fat is great. It means their gas tank is full. Some birds fly from the coast of Maine in the northern United States, and they'll end up all the way down in Brazil for the winter. So pretty amazing that they can fly that far. So I'm going to try to walk. I don't know if my reception is going to improve, but I'm going to try to walk and see if I can get to one of our nets and see if our video lasts. But you guys can keep asking me questions while I do this. Try to track down some good reception.
Cool. All right. Well, while you're looking for the net, Miss Wafer, if you have a second question to pass on or a couple, go right ahead.
Awesome, thank you. So there's three that are kind of connected. Sammy's in fifth grade in the Bahamas, and he's asking about, Sarni, about the band, if the microchip tracks the bird activity. And so then on that note, Ellie in kindergarten, she's in Tennessee, she wants to know how far then, if it does track, what's the farthest that a bird has flown. And then Kitoko, who is in Malaysia, and if you ever see them come back, then some tracking questions.
Cool. So our bands themselves are not trackers, so they're just aluminum, and they don't have any machinery inside that lets us track the birds. But we do, on larger birds, put transmitters on them. So those are trackers that can send out a signal once a day and tell us where those birds are going and where they're staying for the winter. Oh, sorry, I'm hiking. And so, unfortunately for our songbirds, they're too small, and nobody has invented technology small enough for our songbirds to wear. But we're hoping that some scientists and engineers who are good at building trackers would be interested in making smaller trackers. So if you guys are into electronics and engineering, you could grow up someday, build us a transmitter that's small enough for our little birds. That would be pretty cool. The farthest bird that we've tracked, we put transmitters on long-billed curlews for some of our, and they end up in kind of central and southern Mexico. Other groups have tracked other birds like a whimbrel or bar-tailed godwit that go even farther. So Our curlews compared to some birds they're not very long distance migrants, but still pretty cool to get to track them all the way to Mexico. So it looks like I have video. I'm gonna walk down, show you guys one of these nets. Was do we get birds back? And we definitely do, especially in the breeding season. We get birds that nest here every year, and we recatch them every year. So, like, one of my favorites is a little calliope hummingbird that we've been studying hummingbirds for 6 years, and we've caught him once a year, every year for 6 years, and he keeps coming back. So, kind of fun. So here's our net. Let's see if you guys can see it. So it's very, very thin. It's thinner than sewing thread. Really delicate net. And it's attached to a pole here. And then it runs all the way down and down to another pole at the other end. I'm not sure if you guys can see it. So it's about 12-meter long net. And I'm showing this net on the camera, and you guys can't even see it probably. And that's the way we were able to catch these birds. It's really, really fine. This allows us to gently catch these birds, and you can see, let's see, they land in this little pocket, so you can see the net is bouncy, like they're in a little hammock, and sort of gently wraps them up until we can come and take them out of the net. There's no birds in our net right now, but just to give you guys an idea of what we're doing. And I can also show you, the lighting is okay. We have a bunch of choke cherry shrubs and bitter cherry shrubs around us. So these fruits, they're a little bit dried out right now. One of the main foods that a lot of our later fall migrants like eat is these cherry shrubs. So you can see all the way around cherry. So yeah, you guys are asking good questions. I like it. It's fun.
Excellent.
Yeah, you guys are asking good questions. I like it.
Yes, they are. Just so you know, Heidi, it's cutting out a little bit now, your audio as well, so you might be a little too far, but that was great. Okay. We did see the net, even if we couldn't really see the net because it's so thin. Okay. All right, let's go back to Miss Durnan's class. If you guys have a second question. Anyone? It's okay if it's the same person again.
We have one question here. Noah's going to come back here.
We have one question here. Noah's going to come back here.
Back up here now.
What are the effects of climate change on bird migrations where you are?
Good question. So we've seen in a lot of our bird species that they're changing their timing of migration. And that actually, in the end, is probably a good thing. So some species are changing, some species aren't. The species that aren't changing are the ones we're more worried about. So birds use day length to decide when they're going to migrate. But plants, they use the temperature around them to decide when to bloom. Insects use temperature to decide when to come out of hibernation. And so what we're seeing in some species like broad-tailed hummingbird is that they're coming back on time. They're using day length, so they always come back, let's say April 20th. But the flowers use temperature, and the flowers are blooming earlier and earlier and earlier because it's getting warmer earlier in the spring. So by the time the hummingbirds come back, the flowers are already done blooming, and so there's a lot less food for the hummingbirds. We're seeing that in some other species as well. Luckily, we are seeing some species that are changing their migration timing. So that might mean that they're adapting and they're going to actually be able to survive with climate change. So we're doing that research to figure out which species we need to focus on and help the most, and which species are adapting and maybe are going to actually do okay with climate change. But it varies a lot. So some species are doing great and some species are really being affected a lot more than others.
Answer. All right. We're going to take 2 more questions from the kids who've been waiting for some time now. So we'll start with Mr. Elsa's class. Go right ahead.
My question is, what month is most common for the birds?
Oh, so I think September, so right now is probably our peak in migration for all the species we study. So songbirds, hawks, and owls. Songbirds this year, we actually had a really early peak in migration. So in August, it was really busy and we were catching lots of baby birds. So birds that had just hatched earlier that spring and they were moving through. And then now is usually busy. We have a little bit of a lull, so we're probably only catching, instead of 200 birds a day, we're probably only catching 40 or 50 birds a day, which is still a lot, but not as many as we sometimes do. But yeah, September usually, as birds are, they want to leave here in Idaho before it gets too cold and get to warmer places where there's more food. And so a lot of them leave us around this time. We do have some birds, so while you guys are asking questions, I'm going to switch.
Yeah, please do. Let's get one more question from Elk Knob Elementary.
Us.
Your question. Okay. Go ahead.
It's our turn.
What's the farthest one of your birds each travel?
Cool.
Farthest one of that's traveled.
What was the question?
What is the farthest bird you've ever had travel?
Oh, farthest? Well, I know our species like yellow warblers, they travel all the way to Central America, so like Belize and Guatemala. But as far as birds that we've tracked and had recaptured, probably one of our hummingbirds that somebody caught in Sierra Vista, Arizona, which is almost all the way to Mexico. So Leah just told me that this thrush, I don't know if you guys heard her mention this, but this is a bird that one of our other scientists banded 4 days ago, is that right? Mm-hmm. And have we weighed it yet?
No.
So we'll have to weigh it and see. We banded it 4 days ago. Hopefully it's fatter.
It is.
Is it already?
Mm-hmm.
We know? Awesome. Nice. Cool. So that's what we like to see. So this thrush has been feeding, gaining weight, and hopefully preparing for a long migration. So this is a hermit thrush, which they can end up in Mexico for the winter. Oh yeah, hermit thrushes, you can identify them because of that nice reddish tail contrasting with kind of that olive brown back. So, and they have really beautiful spots on their chest and nice little insect-eating, fruit-eating beak. So, yeah, cool. Nice little guy. So that'll be fun to weigh it, this bird, and see once Leah's done measuring it, see what changed.
Yep. Does it have any things on its greater color? Yeah.
So another thing we do is we look at the bird's wing feathers, and that can tell us age of the bird. So kind of like you guys might have a mix of grown-up and baby teeth. If a bird has a mix of grown-up and baby feathers, then we can tell that it's either hatched this year or last year. So we can tell that it's a younger bird. Then if it has all grown-up feathers, then we know it's an older bird. So we can probably take a question while we're waiting. So Leah's taking all her measurements. She'll weigh it.
Actually, Heidi, we're getting pretty long on time, and I know some of the classes might have to go soon. So if it's okay, we can wrap it up there, and then if people want to get in touch, they can send in more questions to you online. Is that okay?
That sounds great. We can end with a grand finale of how heavy this hermit thrush is and call it good for the day.
Let's do it. All right, well, check it out.
Oh, it gained 1.7 grams. I like it. Cool. So it got heavier. That's good.
In 4 days. Nice. All right. Heidi, at the end of every hangout, what we do is I'm going to demute everyone's microphone. So Mr. Elsa's class, Elsa Knob Elementary, Ms. Schaefer, Ms. Durnan's class. If you guys could join me and say a big thank you. Thank you to Heidi. Thank you, Heidi. Awesome. That was great, Heidi. Thank you so much for joining us. We look forward to more hangouts throughout the month with you, and have a wonderful rest of your day.